So looking at the same example we just finished, what I want to do now is I want to do a dot plot on this line just to show you where all these collision claims lie. So you have one at 384, 582, 668, 989, 1373, 1643, 2135, 3871. Then you have some way out here, 17038 and 2147. So we can see that the bulk of the data, we have a lot of lower numbers in this range, and these numbers out here, these collision claims are really affecting everything. It's really pushing our mean out this way. And if you were to plug this in the calculator and find the mean of this, you would get the mean is way out here. This is mu, and that's equal to 4983, which is very far from our median. Refer back to the tables that we drew the graphs we drew several videos ago. This means if our median is here, that it's more representative of our data as a whole, because there are large numbers out here that are skewing the mean to make it look like this could be very misleading if we were to use that number. Our bulk of our data lies around the median here. And so the next thing we're going to introduce is something called interquartile, IQR, and it's going to go along with the median. And and I'll show a comparison of the IQR versus using the mean and everything in a second. So let's define what interquartile range is. Interquartile range. And if you remember back what a range is, just range by itself, that's the largest value, the largest value minus the smallest value. Here, IQR is how we're going to label this from now on, is the range of the 50%, is the range of the middle 50% of observations. In other words, this is pretty simple here. IQR is equal to the third quartile minus the first quartile. So pretty simple there. Let's do an example 2 here, and we'll just say find IQR of example 1. Alright, IQR is equal to, always write the formulas, it will help you in the long run. And we refer back to my other paper here. The third quartile is 3871 minus the first quartile, which is 668, and that's equal to 30,203. And so what this allows us to do is it allows us to, I can compare now. So compare mu and the median from example 1/2. So I'm going to write the mean, the range, and the standard deviation over here. If you plug all this in your calculator, you'd come out with these answers just as easy. So I just went ahead and did this part for us. The mean is 4,983. The range, which is the largest value minus the smallest value, is 20,763. And sigma, the standard deviation, is $7,566.18. Now compare that to using the median and the IQR. So M is equal to 1508. We found that already in our example 1. And the IQR is 3,203. So these are very different numbers. If you compare the mean to the median, those are very different numbers. And even compare the range to the IQR, those are very different numbers. And the standard deviation is rather high. So when we have something that's skewed right, like this graph like this dot plot was, let me pull this graph back up here for a moment. We have, and if it was drawn to scale, it would be more prominent. But what we have is we have a large amount of data over here and very little on this side. So we have, this is a skewed right graph. When we're dealing with skewed right graphs, the mean is bigger than the median, and we want to use the median in this case. All right, so the median here is a better measure of central tendency because the data is skewed right. Let's write that. The median is a better measure of central tendency because the data is skewed right. Also meaning that the median is less than the mean mu. Alright, and part of the reason we want to use the median in IQR when we have a skewed right or skewed left graph is because the range and the standard deviation, sigma, are affected by extreme values. And that definition is called resistance. Refer to the definition of resistance. The range and standard deviation are not resistant. The range and standard deviation, and we'll go ahead and say the mean, are not resistant. Whereas the median is. All right. So, for example, let's go back to our graph again, and let's say that this 21,147, the largest value, let's say we change that to $40,000, so it's way off the page now. The mean is going to get bigger, it's going to move way out here, but the median is still going to stay the same. We would still find our same value here in the middle. So that's why the median and the IQR are better measures when we're dealing with skewed right and skewed left graphs. So I put that in a table form, so let's look at that. So we have we're going to have 3 columns here. And here is the shape of the distribution. Here is the measure of central tendency. And over here is the measure of dispersion. So if we have a graph that is symmetric, then the measure of central tendency that we want to use would be the mean in this case, because the mean and the median are the same thing, or the same value, roughly speaking, when we're dealing with a symmetric graph or a bell-shaped graph. And you would also want to use the standard deviation sigma. And we'll cover more on why later. But if the graph is skewed, left or right, then you'd want to use the median. And we've discussed that several times with this example. And you'd also want to use IQR. Alright, that's it for this video.